So for instance, we know like number one, just 8 minus 7. But I don't put this here because I just want to start you off with the easy one. But I want to explain it to you as like a, this is the same as 8 plus negative 7, right? Now, these are identical. The minus sign is the same as a negative sign. You treat it either way. So when you think of problems like this, when you see plus and negative, it's really something from second grade. We have a tendency to overthink things, make it more complicated. But really, 8 plus a negative 7, that's 8 minus 7. 1. That's it. So keep that in mind. Sometimes it's easier than you think. We make it more difficult than you think it's supposed to be. With positive negatives, I always think of counting. I think of hot and cold. I think of owing money to somebody or spending money and then also getting money or someone paying you. Different ways of looking at it. So, here. If you pay someone $5, negative. You pay someone else $7, negative. How much have you paid out? You paid out $12. $12 altogether. Okay. Negative 12. The negative is just an indicator. Are you paying somebody or are they paying you? Think about it that way. Paying $5, negative 5. Paying $7, negative 7. You paid $12 altogether. I want to get away from all the fancy rules and the little songs you might have learned in the past that maybe work sometimes but get confusing after a while, and just look at it in a more common sense, real life way. What about here? Minus a negative 6. Okay, why? But why? Yeah, so I guess most of you know this is the same as 3 plus 6, but why? So we want to get away from those keep, flip, flip, keep, change, change, and it's just a rule because it's a math rule and it's only used in math and that's it. Think about it this way. Think of this negative 6 as something that's bad, just a negative. Anything that's bad in general. What happens when you get rid of, do another negative, what happens if you get rid of something bad?
You get less bad.
Is that good or bad? Getting rid of something bad, is that good or bad? That's good. That's why two negatives make a positive. This isn't a math rule. This is just how you already think. It's natural. This is not what you already do. This is how you write it down in symbols. That's all. But you already think this way. If we get caught up in these songs and little tricks just to get you the right answer, and you think, well, this has nothing to do with the real world, it's probably because we're using a bunch of songs and a bunch of tricks, and we can't actually make sense out of it. So, yeah, negative number. You're spending money. That's all. Spend $5, spend $7, you spend $12. That's all positive negatives are. Taking away, getting rid of something bad, getting rid of a negative thing. Doesn't matter what it is, in math or any class or in life, that's always a positive. That's always a good thing. That's all. So our answer for this is okay. It's positive 4 degrees. It drops by 8 degrees. What's the temperature now? Positive 4 degrees drops 8 degrees. Now it's at negative 4. It's gone down. Started at 4, went down 4 to 0, went 4 more down to negative 4. Okay? You don't need rules or tricks to do these problems if you look at it in a certain way. We don't have to remember certain rules and songs in order to get math problems right if we know what they really stand for. And of course, you can find ways to really use math in the real world if you're not spending your time using little songs and tricks. And just think of, okay, positive and negative are money. How many jobs do you know that deal with money? Zillion. When are you ever going to use positive, negative numbers in the real life? Pretty much always. You might not say, well, you owe me negative $4. You just say you owe me $4. It's the same thing as a negative 4. That's the thing you got to realize, that we don't use the word negative, but we say you owe me, or you give them a bill, check, it's the same thing. It's all the same thing. Okay, so let's try, let's see here. Any one of these want to go over together? Let's see here. Pretty good. Now, please take the time to rewrite these.
Should we go on the one? I mean, not a motion, average.
Okay. Rewrite them with the new symbols that are a little bit more simplified so you don't get caught up trying to do everything in your head. It turns out we're not as smart as we think we are. We think we don't need to show work, right? We think we don't need to show work and we end up redoing it, rewriting it, or I got that wrong, that kind of thing. Also keep in mind that your first draft is usually not your best draft in any class or anywhere. So just because you write an answer down doesn't mean you're done. We'll get that. I'd sit down to multiplication. A negative and negative is a
Positive.
positive when you're multiplying, yes. For the same reason we just talked about. It's like getting rid of a negative. It's a positive. It's a positive. Now, is a negative and negative always positive? Go back to number 2. Negative and a negative is because we're adding, subtracting. When you're counting, you owe me $7, you owe me $5, now you owe me a lot more. Negative and negative is a negative. So let's not use that rule all the time on everything. Again, if you think about what you're doing, it makes sense. If we just try to use a random rule just because it's a rule all the time on everything, maybe it's just any of these you want me to try out? 23. 23. Alright. 210 divided by 14. Is this answer going to be positive or negative?
Positive.
Yeah, that's the first thing I would put down. Worry about the algebra side. That's the positive and negative, the signs. And let's do the arithmetic, which we learned in 4th grade, to finish it up. But that way at the end we won't forget. We'll do all this work and then all of a sudden have no answer. So 210 divided by 14. Are these the same thing? Are these the same thing? 210 divided by 14, 210 over 14. Yeah. Same thing, right? Right?
Yeah.
So we can write it either way. Up here. Up here. Thanks for you guys. If I can hear you, everybody can hear you. Not just me. You notice how I kind of pause when I'm waiting for people to stop talking, because if I can hear you across the room, everybody can hear you. If everybody can hear you across the room, they can't hear me. I'm trying to listen to conversations. Okay, you're doing the math, but try to stick with me. All right. So a couple ways of doing this. Divide top and bottom by 2. That's one way of doing it. You can say 210. What's half of 200?
100.
What's half of 10?
5.
105. Alright. Divide the bottom by 2, you get 7. That's one way of doing it. You can keep going as well. But then you also might notice, well, 21, 7 goes into 21. Does 7 automatically go into 210 though? Just because it goes into 21? Like you see it. So you can try different ways to see what happens. One of the ways I like the best though is just good old-fashioned prime factorization. You might remember this. That equals 21 times 10, right? 210 is 21 times 10. 21 is 7 times 3. 10 is 5 times 2. 14 is just 2 times 7. So if we look at it this way, we have a 7, a 3, a 2, a 5. That's 210. And on the bottom, we have a 2 and a 7. 2's cancel out, 7's cancel out. What's the answer? 15. You might say, well, I needed a calculator, those numbers are big. Well, not if you use prime factorization. Alright. I'm going to have you guys work together, finish things up. I'm going to call a few people over to register for School Loop. So if you hear your name, come on over here. If you need to, bring something with you so you can write down what your new login and your password's going to be. If you have another website you go to a lot, use the same login and password and you don't have to write it down. Alright, continue working. When you're finished, think of it as a first draft. Check your answers until they're 100% correct.
Right.